Hi, I'm Mike Garjoy from the University of Toronto, and I want to talk to you today about Bender and Koller's Octopus from ACL 2020 and relationship to Occam's razor and how you would teach a paper like that in an introductory NLP class or introductory ML class. So I'll briefly review B&K's Octopus test from ACL 2020. I'll present briefly a possible counter-argument to an application of B&K, and I'll give some very brief thoughts on teaching materials and teaching a position paper that's kind of like this. So first, very quickly, the Octopus test. So you have A and B on two desert islands communicating via undersea cable, via telegraph, and you have the hyper-intelligent Octopus O who intercedes and after listening in for a while tries to imitate A and B, pretending to be one or the other. And the claim in the paper is that it can work, but it can only work so far, because if we're talking about conversations that require understanding some kind of world model, that the claim is not going to work. So here is a very simple example. They also go into physics, arithmetic. So GPT-2 stands for the hyper-intelligent octopus that cannot complete correctly the prompt 3 + 5 =. Of course, as we know, there are models that can do it quite well. And I think there is a deep reason for that. So the reason, I think, has to do with the fact, well, yes, actually, sometimes you can learn to predict just from observational data, and you can build world models just from observational data. Well, look at all of my friends over here who did that by just looking at the sky and building better and better theories that predicted better and better in a more and more parsimonious way. What's going to happen when you go out tomorrow and look at the sky? Good inductive biases are, of course, key. So Occam's razor is kind of particularly prominent in this kind of scenario, more in the paper. So to teach this kind of thing, I think it's actually good to go, in a point, counterpoint, counterpoint format, because, it's easy to present an argument, but it's also easy to poke holes in many arguments. So I have some guided questions in my teaching materials on GitHub to encourage critical thinking about this kind of argument. I also have a video. I have some PowerPoint presentations that's all on Octopus, on GitHub, /Gersh/Octopus. Email me, tweet at me, x.com at me, read my archive paper if you have any questions. Thank you very much for having me.